Hello, so today we're going to look at the factor formulae, and the factor formulae we're going to see they're going to be very important in when we find addition or subtraction of cos or sine. So here, this is a summary of the factor formula. We have cos A plus cos B. This is 2 cos A plus B out of 2, cos A minus B out of 2. So then when we have cos A minus cos B, this is going to be equals to negative 2 sine A plus B out of 2 sine A minus B out of 2. Then when you have sine plus sine, it's 2 sine cos. Then when you have sine minus sine, it's 2 cos sine. So for now, the easy way you can remember them is cos plus cos is 2 cos cos. Cos minus cos is negative 2 sine sine. Then sine plus sine is 2 sine cos. Sine minus sine is 2 cos sine. Where like the first term here, like the cos is A plus B out of 2. Then here the second is A minus B out of 2 for each of these, and here it's A plus B. This is cos A plus cos B, this is cos A minus cos B, this is sine A plus sine B, this is sine A minus sine B, and for each of these, like the first is plus out of 2, the second is minus out of 2. So this can help to remind you, because these formulae are very important, and mastering them is an advantage. So now we're going to look at proofs. So we are going to prove together one, then the rest I think I'll just be showing, then you can follow through. So okay, now we're going to look at some of the proofs of the factor formulae. So we're going to just look for we're going to look at the proof of addition of two angles in a cosine, then the rest we shall just I'll just display and you follow through. So now two angles in a cosine, so we're going to say we're going to assume cos A plus B plus cos A minus B. So here we have this cos A plus B plus cos A minus B. So here this is two angles in a cosine being added, like addition of two cosines, sorry. So now we can expand each of these using the compound angle formula. So this is cos A, cos B minus sine A, sine B, then whole of this plus cos A, cos B plus sine A, sine B. So here, of course, this nothing is going to change in this bracket. This will go with that. So we end up having this is cos A, cos B plus cos A, cos B. So we end up having this is equals to 2 cos A, cos B. Now, so we have cos A plus B plus cos A minus B is equals to this. Now, here we have A plus B, here we have A minus B, and I want to now have like independent expressions, like maybe if we have something here adding on something, instead of having like two things, we're going to say let A plus B be P, and let A minus B be Q. So we have A plus B is equals to P, A minus B is equals to Q. So we now use elimination method. So if we add, this is going to be 2A, then B plus negative B is going to cancel. This is going to be equals to P plus Q. When you divide through by 2, we get A is equals to P plus Q out of 2. Then now we write this expression A plus B, A minus B, A plus B is equals to P, A minus B is equals to Q. But this time we subtract. So this is going to be A minus A is 0. Then B minus minus B, this becomes 2B. This is equals to P minus Q. Divide by 2, divide by 2. So B is equals to P minus Q out of 2. So now we come and substitute both of these into this expression we had. So we end up having cos A plus B, but we said let A plus B be P. So this is P plus cos A minus B, but we said let A minus B be Q. So this is plus Q. This is going to be equals to 2 cos A, but from here we have A is equals to P plus Q out of 2. This is cos P plus Q out of 2 cos B, but we found out that B here is P minus Q out of 2. So this is P minus Q out of 2. And I think you will still literally proved the factor formula for addition of two angles in a cosine. So this is the same concept we're going to keep applying on each of, for addition of two sines, subtraction of two cosines, subtraction of two sines. It's going to be the same concept as we've seen here. Okay, so this is the factor family for addition, for subtraction of two cosines. So you see, this is the proof, you can go through it. Then this is the factor family for addition of two cosines. Similar concept, you can go through it. This is the proof for the factor family for subtraction of two cosines, and this is the proof, you can also go through it. And then now we have a summary of the factor formula here again. So I told us that the easy way we can remember this is cos plus cos is 2 cos, and then sine plus sine is 2 sine cos, and then cos minus cos is -2 sine, and then sine minus sine is 2 cos sine. So you see, for the minus, the cos comes first. For the plus, of like for sines, the sine comes first. Then subtraction of 2 cosines, you're seeing it's -2 sine, and we say that after this first, like everything, the first, so it's going to be a plus b out of 2, and here everything is going to be a minus b out of 2. There, here is a and this is b. So this is a summary of the factor formulae. So this is what we should keep in the back of our minds before we now start looking at the different applications. So the application of the factor formula, we are going to use it to solve trigonometric equations. We're going to use it to in proofs, in proving different identities, then even in proving identities involving angles of a triangle. So that's going to be the application of the factor formula. So now we're going to look at the application of the factor formulae. We're going to start with its application in solving equations. So now we have this equation: sine x plus sine 3x plus sine 5x plus sine 7x. Now, every time if we are faced with these equations, of course, we know that we have to use the factor formula, because there is no other way we can add these signs. But now, like how you choose to pair them matters, because someone could say, let me add this plus this, and maybe this plus this, but you have to know how to add them. Like for this question, maybe adding them like this is going to be easy, but like I'm trying to tell us that every time you're faced with these equations, how you add them matters. So if you try adding them like this and you see you're not coming up with a good answer, then you know you have to probably interchange some few things. And what do I mean? So when you look at this is x, this is 3x, so you know from the factor formula somewhere we shall add this out of 2. So this will be 1 plus 3 out of 1 plus 3, which is 4, divided by 2. So the answer is 2. Then here we have 5 plus 7. And 5, what is 5? Okay, let's do it and we'll see as we work out. So I have sine x plus sine 3x. Remember we said from the factor formula, sine plus sine is equals to 2 sine cos. So now we're going to start. This is 2 sine x plus 3x out of 2 cos x minus 3x out of 2 plus, so this is sine 5x, so this is still sine plus sine, so plus 2 sine 5x plus 7x out of 2 cos 5x minus 7x out of 2. This is equals to 0. So we're going to have, this is 2 sine, this is 1 plus 3, 4, divided by 2. So this is sine 2x. Then we have cos 1 minus 3 is -2, divided by 2, -1. So we have, okay, let me clear that. Let me clear this. So we have this cos -x plus 2 sine. Here we have 5 plus 7, which is 12, divided by 2, it's 6. We have plus sine 6x cos 5 minus 7, that's -2, divided by 2, that is -1. So here we have, this is -x is equals to 0. Okay, so we have this. Now, one thing we have to note, as we're starting trigonometry, when we're looking at the trigonometric graphs, we realize that let's try maybe what is the cos of 270. Okay, let me try the cos of 90. Okay, let me say cos 180. So we saw that. Let's try 180. So cos of 180, when you try with your calculator, is -1. But when you also try the cos of -180 from your calculator, it's also cos of -180 is also -1. That means that when you have cos and there's a negative inside, that negative like doesn't have an effect on that. It will just, even if you write it in a positive way, nothing changes. But when you have let's see let me try sine, maybe sine of let's say, but when you have sine of 90, sine of 90 is 1, but when you have sine of negative 90, this is negative 1. So what does that mean? Sine of 90 is equals to sorry, let me start. Cos of negative 180 is equal to cos of 180. You see, so when I have a cos with a negative inside, I can just make it a positive without, but if I have sine of negative 90, this is the same as negative sine of 90, because you see that sine of negative 90 will be negative times this 1, so it's negative 1. I hope that makes sense. That's why here when I have cos of negative x, I can write this as, this is 2 sine 2x cos x plus 2 sine 6x cos x is equals to 0. Why? Because I've told you that when you have cos of negative x is the same as cos of x, and I've explained to you why. Now when we have this, you look for what we can factorize out, and from this you see we can factorize out cos 2x. So we can factorize out cos x. So here we have we factorize out cos x. So here what we have? We have cos x into 2 sine 2x plus 2 sine 6x. This is equal to 0. So I think we can factorize out this 2. So this is 2 cos x into sine 2x plus sine 6x is equals to 0. So this here we have either 2 cos x is equals to 0 or sine 2x plus sine 6x is equals to 0. So we can now start with this one, 2 cos x is equals to 0. So 2 cos x is equals to 0. So here we're going to say cos x is 0 when the 2 goes the other side. So we said for this you can obtain the value from the graph. So you can draw the graph, but I don't want to draw it because of time. So you can see x is equals to 90, but the other values, okay, let me just draw it here. So we have, this is the graph of cos, then I have 90, I have 180, I have 270, I have 360. Then here I can have negative 90. So then here 1 and here negative 1. So the graph of course comes like this. I hope you know how it comes about. We just get this. So this axis is cos theta, this axis is theta. So now we look for 0, and 0 is here on this line. So meaning on 0, what do we have? We have 90, we have 270. So here, comma, 270 is also part. Okay, so we have x equals 90, comma, 270. Okay, now we continue with what we had here, or sine 2x plus sine 6x is equals to 0. So here I would have sine plus sine is going to be 2 sine cos. It's going to be 2 sine 2x plus 6x out of 2 cos 2x minus 6x out of 2. This is equals to 0. So this is 2 sine, and 2 plus 6 is 8. Divide by 2, that's 4. So 4x, then we have cos 2 minus 6, that is negative 4. Divide by 2, negative 2. So this is negative 2x is equals to 0. But we said if it's a negative, so this is going to be 2 sine 4x cos 2x is equals to 0. So we see what we have. So when I divide through by 2, this is going to go. So we're going to have either sine 4x is equals to 0 or cos 2x is equals to 0. So since we already have, so this 2x is going to be equals to the cos inverse of 0. Since we already have the graph for 0, we just come here on like 0, this is 0. I hope you can see where the cursor is moving. This is 0. So I just look for the points that coincide with this. So I have 90. So 2x is going to be equals to 90 is the first angle I see. Then I move here, I find 270. So comma 270. And I think after 360, let me see what is 360 plus 90. Here I have 450. And when you go further, even 450, the cos of 450 is 0. So even 0. So even 450, sorry, is 1 is part. So I divide through by 2, divide through by 2, divide through by 2. So I get the value of x as, this is 45, comma 135. But now for this, when you divide, let me see, 450 divided by 2, you get 225. So 225 can include it because the question wants theta. Okay, 180. So this is excluded because the question said values of theta between 0 and 180. So now we come here for sine 4x being equals to 0. So let's plot the graph for sine. I think I'm going to pause the video, then I plot because it's going to take time, but I want to show us how to plot. So 0, then we go to 90, then we go to 180. You get the multiples of 90, 270, 360, keep going. Then if the question also wanted negatives, we got the negative side. Here is 1, then this is -1. In one of our first videos, I show us how we plot this. You start from cos, you start from, this is a graph of sine, so this axis is sine, then this is graph for alpha. So you start from what is a sine of 0, you plot. What's the sine of 90, you plot. What's the sine of 180, you plot like that until you come up with your graph. So let me pause and plot that. Okay, so now we look for, in this graph, we look for where 0 is. So 0 is one of the, so okay, we come here and say 4x. 4x is going to be the sine inverse of 0. So 4x is going to be equals to, the first one is going to be 0, then 180, then 360. So here we can divide through by 4, divide through by 4. Each of these, divide by 4, divide by 4. So our value of x is going to be, our value of x here after dividing through gets 0, comma, then 180 divided by 4, we get 45, then 360 divided by 4, we get 90. So the values of x for this question, you just have to rewrite x is 0, 45, 90, you add 135, and these are the values of x. You can even try to prove by substituting here and you're going to get the same answer. Okay, so now continuing with solving trigonometric equations involving the factor formulae. So now here we have this question saying sine x plus sine 2x plus sine 3x. Now you're going to be faced that in solving trigonometric equations involving the factor formulae, you're going to find that some questions, if you have to rearrange them for you to solve the question perfectly. Like now for this, it is sine x plus sine 2x, the way it's given to you in the question. So now someone could choose to apply the factor formula to these two, then now add this, and this is how it would be. You have sine x plus sine 2x plus sine 3x. You apply the factor formula on these two. Sine plus sine is 2 sine cos, so this is what we have. Then you eventually come out with 2 sine 3x out of 2 cos this plus sine 3x. Of course, this is equal to 0, this is equals to 0. Now you see for this question, you reach this point and you're stuck. Why are you stuck? Because you're supposed to rearrange. For example, when you look at, you have sine x plus sine 2x plus sine 3x. So now every time you're faced with these equations involving the factor formula, for some, you're going to actually just add and it will come out. But usually you should try to look at, here it is x, here it is 3x. So you know when you say x plus 3x divide by 2, you get x plus 3 is 4x out of 2. You'll get a 2x somewhere, and there's also a 2x here. So just by that, you know, you may have to factorize out a sine 2x somewhere So as you're trying, you always try to look at these terms inside the angle and you try to compare. I don't know if that makes sense. Now let me show you if someone had rearranged this. You see, if you rearrange this, you have sine x plus sine 2x plus sine 3x is this. So you rearrange and say sine x plus sine 3x plus sine 2x is equals to 0. Then you apply the factor formula on this. So you end up coming up with sine 2x cos this plus sine 2x is 0. But remember we said when you have cos of negative x is the same as cos of positive x, because cos that the graph of cos is symmetrical. So we come up with this thing here, you factorize out sine 2x. So either sine 2x is 0 or 2 cos x plus 1 is equals to 0. So you solve and always make sure that you exhaust all the angles, because that is why they give you a range, and make sure you get the angles within the range. So now we have another question. This is cos 5x minus sine 2x is equals to cos x. So for this question, you cannot apply the factor formula on cos minus sine. So you bring this cos this side, or you can take the terms the other side. So for us, we chose to bring the cos this side. Then we now apply the factor formula of cos minus cos, which is negative 2 sine sine. And so we worked out, and as I've said, remember to always exhaust all the possible angles that can solve the question and try to follow the range within which the question is asking. So this is how we solve this. Okay, then after this one we have sine 3x minus sine 3 theta minus sine 2 theta minus sine 6 theta is equals to sine theta for these degrees. Now here, as I told you, the first time we're going to bring this sine on this other side, and we can try to rearrange, but for this specific question, as you see, someone could have just chosen to work it out the way it is. But you should always note that when you have them, like you have four terms like this, and especially when they are negatives, these last two terms, like you're supposed to put them into a bracket such that you don't confuse, because now this looks like negative sine 6 theta minus sine theta, yet we don't have a factor formula which says negative sine minus sine. So you arrange it to look like one of the things we have in the factor formula identity. So this is sine plus sine, but into with a negative with into a bracket. So we expand this like this. Then we eventually we factorize out this term somewhere, and then you work this out, either 2 cos this is that. Okay, so you, after applying the factor formula on the expression, you come up with this expression. Then after you factorize out the common term in both, so this case it's 2 cos 5 theta out of 2, and then you have either 2 cos 5 theta out of 2 is 0 here, or this is equals to 0. So you solve and you find each and every angle. But then another person would have said that this is sine 3 theta minus 2 theta minus sine 2 theta minus 6 sine theta minus sine theta is equals to 0. Then now they rearrange and say this is sine 3 theta minus sine theta minus, so you rearrange it. So you see here the work looks somehow smoother because you don't have fractions. That's what I told you, that when you can try to examine the angle. So here it's 3 theta, here it's 2 theta, here it's 6 theta, and here it's theta. So you try to compare and see if you get 3 theta and theta. So 3 theta plus theta will be 4 theta divided by 2. You'll get 2 theta. And then here you have 2 theta and 6 theta. So you choose to work with this, because even when you say 6 minus 2, you'll still get a 4. Divide by 2, you'll get a 2. So that's why we have this then factorizing out. To factorize 2 cos 2 theta. Then always make sure to quote all the angles depending on the range given. So this is the answer you get for that. And then now we have this. So same thing here, I have sine 2 theta, sine 10 theta. So apply the factor formula to this. So you see, apply the factor formula to this and you work them out like that, and make sure you find all the angles. Yeah, so that marks the end of the chapter on solving trigonometric equations involving the factor formulae. So we can try out these numbers, and the answers are given in the brackets.